Welcome to topic 3. I knew I had this backwards.
Whoa.
Welcome to block 2 in topic 3. I thought it looked funny. This starts on page 67 in your workbook. Go back and forth here. Okay. I don't have a workbook in front of me, so let's see. Number 1 says, hold on, let me get my stuff together.
You want me to read the one?
No, I'm good. Study the pattern in the table and the graph. Can you write a rule to determine the number of cups of yellow paint you will need for any number of cups of blue paint? Write your rule in words. So look at the chart and look at the graph. Look at it with your table and see if you can see what's happening every time with the blue and the yellow paint. You're not raising your hand, you're discussing it with your group. Who wants to share their rule that they figured out? What'd you figure out?
It's doubling times 2 every time.
It's doubling what? What's doubling? What's doubling?
Okay, you double every paint that goes up, you double the yellow paint, right?
That's not what's doubling here. What is this here?
The blue paint.
The blue paint is getting doubled to create the yellow. So yellow is, for every blue, you're multiplying it times 2. Is that how you're getting each number? Does that work every time?
Yes, ma'am.
Okay. So write what you said under 1A. You said cups of blue paint is getting multiplied by 2 to get yellow paint. Cups of blue paint is getting multiplied by 2 to produce yellow paint. Cups of blue paint is being multiplied by 2 to get yellow paint. Cups of blue paint is getting multiplied by 2 to get cups of yellow paint. You multiplying the blue times 2, and that's telling you how much yellow.
Going down.
Oh. All right. So the next slide is helping us with 2B in our, or no, not 2B, 1B, huh? 1B is next. So we're looking at the process. And we see for the first paint, we have 1 set of 2. The second batch of paint, we have 2 sets of 2. The third set of paint, we have 3 sets of 2. Colby? No. And the 4th batch is 4 sets of 2. So write that for your, it's in your book, the table. So each time we're adding another what? 2 to the previous batch. Writing this in your table. On 1B. Okay, so we're going to use that to help us write an algebraic rule. An algebraic rule is just an equation. We wrote an equation last topic, like y equals k times x. That was an equation. So we're going to look at an algebraic rule, and we're going to let cups of blue paint represent what letter? X, and we're letting cups of yellow paint represent what letter? Y. Okay, so that's what it's representing. X and Y, those are called variables. Variables are letters representing some topic. It could represent dogs, cats, paint. What else? House, volleyballs, money, people, anything. That's what variables do. They represent anything. In this case, X is representing cups of blue paint and Y is representing cups of yellow paint. So I'm using this table to help me come up with an algebraic expression to help solve this for any amount of cups of paint that I have. So I first see that my variable is changing every time. It changes from a 1 to a 2 to a 3 to a 4. Because that's how many different cups of paint, of blue paint. It's changing every time, right? So I'm calling that X. That's my variable X in my equation. What is staying the same every time? Times a 2 is staying the same every time. So depending on how many blue cups I have, what am I multiplying it by no matter what? 2. No matter what number of blue paints I have, I'm going to multiply it by 2. Didn't y'all come up with that earlier? You said times 2. So I've just came up with an algebraic rule. Here it goes. They wrote y is going to equal whatever 2 times that variable is. Y'all don't have a spot on your book for that?
No.
On the table? I think it goes with a problem. So let's write this equation next to your table. Write y equals 2 times x. Write that out next to your table. Y equals 2x, or 2 times x. That's my algebraic equation. The number 2 is called a coefficient. Have you heard that word before? Maybe last year. Coefficient is a number in front of a variable. Coefficient. We're going to have that as a vocabulary word here in a second. So that leads us to question 1C. It says, what is the coefficient of the rule on 1C? What is my coefficient of that algebraic rule? 2. So write 2 for 1C. My coefficient is 2. Okay, looking at this next slide, we see blue and yellow. We're looking at the ratios of blue and yellow, and it says we have 2 yellow for every blue. So if I look at a unit rate, that is 2 yellow per 1 blue. That is our ratio and unit rate. It's all related. Okay, so the next slide here, they turned to 0 cups of blue paint. Well, how many cups of yellow am I going to have if I have 0 cups of blue?
0.
0 yellow. Does that make sense?
Nope.
Well, if I have no paint, no blue paint times 2, well, what is 0 times 2? 0. That's how I ended up with 0. So it says, this rule applies, can I ever make green paint without that blue?
No.
What is required, what 2 colors are required to make that green color?
Blue and yellow.
Blue and yellow. So without that blue, there's no green paint being made. That's what it means in the context of that problem. And I think that goes with problem 1D. It says 1D. It says, does this algebraic rule make sense for the scenario? Why or why not? Well, that goes back to the question we just went through. Actually, let's go to 1E, sorry. What did we just say with 1E? The question said 1E, what would happen if you had 0 cups of blue paint? How many cups of yellow paint would you have? How much would you have? 0. What happens? The first question says what happens? Well, what happens? Can you make green paint? No. So, right, you can't make green paint without blue. That is E.
Oh, E.
We've skipped D for right now. We're on 1E. And it was 0. And you can't make green paint without blue. So now that we've written an algebraic expression, or what a rule, or an equation, we have talked about 4 different representations. What are the 4 ones you see on the board? They've been in a table. What else?
A graph.
A graph. We've seen it in words.
An algebraic.
In an algebraic rule. All 4 of those we have talked about now. And all of these problems mean the same thing. So with your group, look and find what is similar between all 4 of those problems. There's one magic similarity between all 4 of those problems. Give you like 30 seconds with your group to figure out what is the similar magic something. So, Braden, what does all 4 of these have in common?
They all each have a constant proportionality of 2.
They all 4 have a constant of proportionality of 2. The table, I see the unit rate of 1 to 2 ratio, so that says the constant of proportionality is 2. I also see that in the graph, because that first point shows me that unit rate, which means constant of proportionality. The verbal tells me, in the algebraic rule, the coefficient is 2, so that is my constant of proportionality. Alrighty then, we have 4 different ways. So let's move right along. Now we're going to just use these 4 different ways. So they are pouring 1 cup of blue, 3 cups of yellow. Is that the same green color we've been working with?
No.
No, it has a different
Color.
vocabulary word.
Oh, constant proportionality.
It has a different constant of proportionality or ratio. So I want you to take a minute with your group and complete. Is this in your book? Is this problem 2, maybe? It is? Okay. Problem 2 it gives you a spot for a table and a graph. Bless you. I want you to take a second to fill in the table and plot the graph, and we'll come back and check it. And see if you can go ahead and figure out the algebraic rule. I think some people already know what the algebraic rule is, so just write it down. You're filling in the table, the graph, finding the rule. The last row is used for your algebraic rule. So you're going to put an x underneath the 4, because that's your x variable, and figuring up your algebraic rule. Alright, so let's see the verdict. We have our process there, getting our y values, checking your table. Okay, and an equation, we're letting that cups of blue be x. And we know x times 3, because 3 is what's happening every time, being multiplied by 3. So my algebraic rule is y equals 3x. How'd we do on that? Did y'all get the equation? Okay. We can go ahead and write the equation for 2b, because that's what it was asking for. Y equals 3x. Circle problem 3. We'll come back to problem 3 later, or it might be homework if we run out of time. Circle problem 3. And I'm moving to, it might be 4 on your book, I'm not too certain. Is this what number 4 looks like? Okay. And it says, do you notice anything about the relationship between the graph and the algebraic rule that describes it? So look at each graph and look at each algebraic rule that's on the bottom. Raise your hand if you see anything.
They have a constant proportionality.
Explain.
Oh, on the green paint mix, or mix number 1,
Yeah.
it's a constant proportionality of 2.
Okay, you see that from the graph?
Yes, ma'am.
And how does that relate to its equation?
Because it multiplies by 2.
Oh, because it multiplies by 2. Very good. So, what is my constant of proportionality on the blue line? 3. So what is that shown in my algebraic rule?
Yes, ma'am.
Yes, by 3 times x. So are these two graphs similar?
Yes. No.
Well, I'm going to ask a few different questions. How are they similar?
Because they're both they're proportional.
They're both proportional because they're both straight and they're both going through the origin. Agree or disagree?
Agree.
Okay, well let's focus and quit doodling. How are they different?
Well, the first one goes by 2 and the second one goes by 3.
The first one goes by 2 and the second one goes by 3. It's constant of proportionality. Okay?
Yeah, but
what did the X represent last problem? What did we say X was going to represent?
The blue paint.
Cups of blue paint. And we said Y was going to represent the
yellow.
cups of yellow paint. So that's still making sense here. So looking at this first ordered pair on the red line, the X is 1. So how many, what did we say X was? Blue paint?
Blue paint is 1.
So how many cups of blue paint do we have?
2. Or
X is 1.
Wait, 1.
1, so how many cups of yellow do we have?
2.
2. At the next point, we have
2 cups of blue paint.
2 cups of blue and then
4 cups of yellow.
4 cups of yellow. The next ordered pair, we have 3 cups of blue, 6 cups of yellow, but all of these on this red line is making what color?
Green.
The same shade of the green color.
I won't test that out. I'll see if that actually works.
You probably will, hopefully. So what does this 3-9 ordered pair represent here? What does the 3 mean?
3 cups of blue paint and then yellow, and then the 9 represents the yellow.
3 cups of blue paint and 9 cups of yellow paint. Is both graphs making the same shade of green paint?
Yes. No. Yes. No.
No, because they have different
Proportionality.
constant and proportionalities. They're both making a green color, but one's going to be darker than the other one. Which one do you think is going to be a darker green based on the constant of proportionality?
Number 2.
2's going to be darker?
Yes.
It has more yellow.
Oh yeah, the lighter the color, the lighter the paint mix.
How many yellows per one does this have?
Oh wait. Oh
This has 3 yellows per blue.
So
This has 2 yellows per 1 blue. So who's going to be darker?
the green
Number
mix.
1.
The mix number 1. Still question number 4, but going back to your book, I think. Loading. Okay, so we're looking at mix number 1, and we can look at its constant of proportionality. What was its constant of proportionality on mix number 1?
2.
2. Let's see what they do here. Well, they're pouring the paint out.
Wow.
Ah, now you made it.
Look at the arrows.
They
They ran 1 and rows 2. And they knew that the constant of proportionality would be 2. Let's look at next image. Here's mix number 2. They're pouring this one out. And they are running 1, but how much are they rising up this time? 3. So that's a little different. That's how their rules are different. See what they're doing next. Comparing the 2, blue has a steeper line. Do you see its steeper line?
Yes, ma'am.
It's 3 times as much as yellow paint, where red line is how many times as much?
2 times.
2 times as much. Some people are not focusing. You're just sitting there, sitting there.
Sorry for the question.
So what?
Sorry, I had a question.
You're lying.
Okay? Notice how when x is 1, what is that y value telling me? We've already discovered this like 500 times. What's it telling me?
How many cups of yellow?
I gotta think.
When x is 1 in my ordered pair, what is this number 2 or number 3 telling me? My constant of proportionality, which is my algebraic rule, my coefficient of my equation. It will always tell you that. So, last slide here. I think I jumped the gun here. This is going to problem 5, maybe?
Yeah.
No.
Yeah, you jumped a lot of space. Yeah. A lot of guns.
She made it.
No, you jumped all the way to number 6. No.
Okay, so let's go through the problems in your book for problem 5.
Wait. Fine. Okay.
Problem 5A. We'll look at 5A.
It's not the same. I blame my license. It's not
It says, how can you identify the constant of proportionality in a graph? Going to my graph here, how can I tell the constant of proportionality in a graph? When the y value, when the x value is 1, it's going to tell me my y value. That's what we just talked about. When x equals 1, the constant of proportionality is your y value. This is 5A. So these ordered pairs told me when x was 1, the y value was my constant of proportionality. B says, how can you identify the constant of proportionality in an algebraic rule? These are algebraic rules. What is my constant of proportionality in number 1? 2. What is my constant of proportionality in 2? 3. So what is telling me, what is that word we just learned of a number that sits in front of a variable? A coefficient. So the how do you spell coefficient?
Coefficient.
N-T. That's a I-E-N-T. The coefficient in the rule is what tells me the constant of proportionality. That is 5B. Jake. And 5C says, how can you identify the constant of proportionality in a table? If I'm looking at a table, I can always take y over x. Your y value divided by your x value. Well, what was my y value in number 1 mix?
1.
What is my y value?
2.
2.
Oh, wow.
Divided by, what is my x value? 1. What was 2 divided by 1?
2.
Isn't that what my constant of proportionality was? Same thing with mix number 2. What's my y value? 3. What's my x value? 1. 3 divided by 1 is 3. That's how I knew it was my constant of proportionality. So if they gave me a table, all I have to do is y divided by x. Alright, you need 2 sticky notes to wrap up this section. Your homework is going to be problems 6 and 7 and number 3 since we didn't finish it. But our 2 sticky notes is this 2 information that we learned. So copy those on sticky notes, then you're able to get started on your homework. Like, subscribe, and
Hit that little bell.
turn on those notification bells